All right, so let's look at the another data set here. This one deals with the bank's failures. So first of all, let me import this pandas as PD, right? And let me going to take this as a variable pd.read_csv. Then let us go and grab this file from there. So banks.csv. Then from here, we take the raw file. I'm going to copy this. Let's gonna paste it here. Right. Let me run this the banks door head. Right. So let us run this right now. You're gonna see this right now. This. Let me make this into rear view. Right. We have to give the dot over there. Right. So it's not enough to look at this because we have about, let's say, print of banks.shape. Let's look at the data first. So how many columns? We have 7 columns and 533 data, right? So, but there are very lengthy names of that, so it's actually not enough space to show up here, right? So let us leave this as it is, or else you can actually say that banks dot iloc, where you want to display only the 5 over here, display only the 2. Let's say this is it, right? Bank name, the city. We have, if you wanted to know the columns, banks.columns here, then it will tell you the bank name, city, st, set, there are different things, the closing date and updated date we have it here, right? So what we can do with this, we can say we can actually need to convert it, this closing date and updated date. First of all, let's say if you want to see those data, let's say right now, here we can say the last 2, let's say here, you can say -3. So the closing date, the updated date that we have, right? But if you can understand what types of data that we have it here, info method will tell us everything in detail. So everything is an object basis, right? But we have the closing dates and updated dates we have over here. So is it possible to convert them into the proper date time format? Yes, we can convert them. You can convert using the pd.to_datetime using that way, or else by the time that you're reading the data frame itself, there is a parameter called parse dates, right? It can directly give you this. Let's say these are located in 5,6 locations on the column basis. Let us run back this cells. So it will tell you there is right now the datetime formatted. So instead of converting in in a individual lines, taking that pd.to_datetime, we can directly give the parse dates parameter by the time that you're reading, from reading through this CSV, read CSV function. You can directly pass this. So these are the column locations, 5,6, I'm saying it. Because how come I came to know that there are only 7 columns? So index starts from 0, then definitely the last 2. The last 2 are 5,6, right? So we can give it in that way. Those gets directly converted. If you do not want that way to be converted, you have to take, again, the closing date, take into one column, then pd dot like this, pd.to_datetime, and pass the column name that you want to convert that. Then take it into the one variable, and you can actually create that column onto the same bank's data set. You can do that way as well. However, the point is here, let's say that we can, so my bad, we can parse out in a sense we're trying to convert, right? We can parse out the date by obtaining the quarter, right? That means 1/3, and year, right, in which the bank closed. So we're trying to find the answer for this. We can parse out the date by obtaining the quarter and year in which the bank's closed. So in order to do this, so let's say, what I'm going to do, banks of. So I'm going to create two new columns on the same data set here. Say the closing underscore quarter, I'm saying it, right? Then I'm going to say here the banks of closing year as well, right? Then is equals to, and let me take into the table. We can take it in the form of list also. There is no question about it. So, but I have to provide two values for this because I'm going to create the closing quarter and the closing year, two new columns on the bank's data set. So we do not have such the closing quarter and closing year because so we say that we can parse out the date by obtaining the quarter and the year in which the banks closed. So we were trying to find out the quarter and the years in which the banks were closed. So I have to pass two values here. What I'm trying to do here, say banks of, we have a closing date. Say you see this closing date, right? So I'm trying to pass a closing date. We have a space there, date, right? If I want to access from this closing date, if I want to access from this, if I want to access only the year or a month or a day, how can I do that? We done this in the previous session. Say dot, right? So dt, which is, it's something like we have discussed already this about it. It is going to refer to the the date formatted, datetime format. So the closing date, it is referring to this particular column. Then the dt is going to perform, it's going to be subset few things. It is going to access the year separately, it is going to access this month separately, the day separately if you're going to use this dt, right? It is not something that I define somewhere. I did not define this variable somewhere. This is a predefined a keyword where we actually going to use this variable on the dates to get only the subsets of the dates, a year, month, a day, like that. So I'm going to say here the quarter. So we don't have any quarter like that, but I'm saying it from this month, the quarter month. So you're going to get to know that quarter month, right? So I gave here the one, so I need to provide another one because this is for the quarter, closing quarter. So the closing year, I have to provide another value here saying that, so the banks of, so it's a closing, capital C, the dot space date, and I have to say dt dot year. So we're talking about this year, right? So this is all about, then look at this right now. Print of the banks dot the columns. Look at these columns first of all, then print of banks dot ilog of very first 5 or 6, whatever it is. Then I'm saying to say here the last 3 maybe, right? So let me run the program. Then look at here, we have a closing quarter and closing year, right? You can just count it, right? It's simply going to give you the same, right? The closing quarter, the quarter in sense, the third, the quarter is, we call it as 3 months, right? Like that. The closing year is the same years of this, right? So even if you look at the last 5, if you want to look at the last 5, then say that here the minus 5, then it's going to increase to the step by 1, then it's going to give you the last 5. Look at this, right? The last 5, right? So we have it 2014, 2000, 2002, 2000, all these things. Yeah. So coming to the point here, we have this. Now let's calculate. Now we can calculate how many banks closed in each year. So the closing underscore year is equals to, let's say, banks dot, right? Banks dot. We have a closing year, right? So banks dot. So I'm going to group by, let's say, then I'm saying that here the closing year. Hope you understand what I'm trying to do here. So let me going to find the size of this. So if you want to print this in the closing year, you can print it out this. Then alternatively, we can also calculate, let's say, alternatively, we can calculate how many banks closed in each quarter of each year. So my bad, right? So let me increase the size, maybe guys going to be visible. So my bad. All right. So let me increase. Yes, this is better. So the closing year I'm going to take. Oh my bad. Right. This closing year and the quarter for this quarter. Quarter for this year and month. The quarter is this 3 and the closing year is 2001 because the closing year is 2001, right? The point is here. So we're trying to group by the closing year. So you're trying to get 3s under one group and 2s under one group and 1s under another group. All the 4s into one other group, right? So trying to find it, the size also, if you want to know the size of this. So the closing year of this, right? Then also say this, then what we are saying, the alternatively we can find out how many banks closed in each quarter of each year, let's say. So let's say, saying that alternatively we can calculate how many banks closed in each quarter of each year. Right, so let me drag this little right side and see the closing underscore. So you understand this point, Desmond? Yeah. Alternatively, we can calculate how many banks closed in each quarter of each year, right? So you'll understand it right now. Say the closing year versus this. I'm taking one new variable here, the banks dot. So never mind if I'm taking the weird kind of variable names, right? Just try to understand it. It's my headache to write it, keep on writing those things. Closing year. And so I'm trying to take another one here, the closing underscore quarter. My bad. Quarter. Then I'm going to take their size. Then print, if you want to know the print, the closing year, your dot desk. So very fine. Let me run this program. So we have so many things, right? We have so many things, so many things, right? So yeah, closing year, closing quarters. So you don't understand it normally because it's actually grouped by, it's grouping together in the same way. So wait, you'll come to know. If I put a graphical pictures by, let us plot actually, let us plot these results. Let us plot these results on graph. Say, I'm commenting this. Import matplotlib.pyplot as plt. Then fig ax is equals to plt.subplots. right? Understanding?
Yes, sir.
Then I'm saying that here AX is equals to then closing year dot plot where I'm trying to plot it. Then you can actually show the figure directly. So what I'm trying to take here, the closing year. So let me comment this all first of all. There's things not to get confused, So say this right now. So we have a closing years, right? So closing years is this, right? In the closing years, and we're trying to find out, it's graph on it. So how many things that is there for, because we already see the closing year is this one. We're trying to group closing years, right? Grouping together the closing years. That means, if you have the closing year is 3, then you're trying to combine those together at once. 3 is under one group, 2 is under one group, like that. You can see this right now here. Yeah, 2 is under one group, 1 under one group, 4 under, all 4s under one group. Yeah, that's what you're doing it normally. Good to go? Let's say here, the closing year. So let's say if you wanted to know here, let's say the print of the banks of, let's say closing underscore year. So we got this column basically. I'm going to use value underscore counts. Simple as this, right? Let me run this program. Now look at this. In 2010, the data is 157. 2009, the data is this, right? Right? Good to go, guys. These many are there. If you can look at to 2000, if you can let's see this 2000, we got 2. The 2 is over here. In 2002, that is 2003, we got 3. So 2002 here we got 3, right? In 2005, like that. If you look at here right now, 2010 we got 157. This is over here. Good to go. Good to go. So based on years basis, I'm trying to draw a graph. When I look at here, the 2000 is we have only 2 data that you're trying to go to over here, and 2003, 7, 1, 4. If you can just calculate all of them, so definitely we got 2001s or 4. See the 4 times here. So trying to graph it same way. So if you can look at the highest number of data which is having 2010, 157. If you can look at here right now, there's this one peak side. This is definitely 2010, right? Right. So coming to the other point, if you wanted to look at the other graph as well, the other side, fig x, so my bad. I'm taking same kind of variables, never mind it. KLT dot subplots ax is equals to closing year underscore q. We got q, right? So this one, yeah. So I'm going to plot it this figure dot show. Look at this, we're going to get 2 graphs right now this. So if you want to count this, let's say the same thing, the print of the banks of the closing. So we got this anywhere the column? No, we don't have anything such. We don't have anything such column which is exist in the banks. So we cannot count it then anyway. But I'm trying to group by the closing year and closing quarter together, right? So we have only 2 things right now. The closing year here and the closing quarter, right? Then I'm trying to find the size, of course, I'm going to use that anyway, right? We got, it's going to give you in the same way. In each quarter, how many banks are closed, it's trying to show this. Then in each year, this is in each year, how many banks are closed, this is this. Yeah?
Yes.
All right, now we're going to work with the stock data. When commonly seen the type of dates, the commonly seen types of dates in the No, it's a very common in stock prices normally. So in order to work with the real time, it's not real time. So there is a library called, pandas underscore data reader, which is going to pull the data. That is, the loaded data. It's not going to take the real time data, but it's loaded with the some data. So in order to work with that data, we have to install the pandas underscore data reader, right? So hope you guys understand how to install this. Use pip to install it on your, on your systems using it's on under command prompt. Then, right? So we already installed it on this system particularly. Now let's say how to get the data from the internet right now. Say import pandas underscore data reader as PDR. I'm saying it. I'm going to run this line. So all right. So stock data.py. I'm saying it. Then I'm running this line. You're perfectly right. So there is no error because it's already installed this package on the system. Then let's say, then in this particular example, we're trying to pull the data of the stock information, right? Let's say, let me write all the things here. So in this example, we are getting the stock information about Tesla, right? There are so many things. Even if you want, you can actually check those codes. The Tesla code is actually, TSLA. There are different codes available for different companies. And if you can actually go to the yahoo.com for finance, right? Finance, right? You can go here. We can type here the TSLA. Then you're going to get the Tesla's one. See the Tesla's included, right? Even if you wanted to, get other data, so I'm going to use this data, but I'm going to, if you want to use any other data, you can actually happily find out, over here in this page, FB, Incense, Facebook, NFX, sells and Netflix, right? There's so many other, right? So it's moving up, right? You can actually see the many other things. You can even search the relevant Amazon, Google, right? Alphabet included, Baba, Alibaba, right? All of these things. So, but I'm going to use the TSLA right now for this example. Then say this one right now. The Tesla, I'm taking as a variable itself, the PDR, get underscore data underscore, this is a function. In fact, this is a function which helps to pull the data from this particular package, right? This is something like you have to mention the code, not Tesla. This is TSLA, right? Then I'm going to do this and print off the Tesla dot head. Look at this right now. All right, so we got the data. So if you want to look at this way, say, all right, so we got the date, we got high, low, in the stock prices, normally what is a high price, what is a low price, what is the open price, what is the closing price, how many people are trying to invest on it, what is just adjustment closing, right? All the things matter, right? If you're very interested in the investments, you actually know these kind of things. The most of the MBA candidates looks for this kind of analysis, right? So we are not into that analysis type. So, but however, as an example, I'm teaching you guys on this right now, right? So first of all, can you just observe right now here, we have this, we have this right now, the index itself, a date. This is an index. This is not a column. These are all columns. These are the data for the columns, but this is an index one. That means we don't have a 0 1 state sequence of numbers. We have the date itself as an index. Suppose if you wanted to make this column as a column in the data, if you wanted to make this index as a column in the data, how we need to do? If you wanted to make this index itself as a column in the data, how you need to do? So
We use the ignore index.
let's say if I wanted to make this index, this is an index, this is not a column. If I want to make this index column, index thing as a column in the data set, so what I have to do in sense, first of all, Tesla of, let's say, the date, I don't have this date column, is equals to the Tesla dot index and Tesla dot head dot to underscore swing. Let me comment this one. Look at this. We got a date, right? Suppose if you want to make this column as a sequence of values, Tesla dot index is equals to range of 0. So we don't know how many values are there, let's say. So what do you need to do? The Tesla dot shape of 0 is number of rows. Simple, it's going to generate this over 0, 1 to 3. The date we got it. And if you wanted to know Tesla.info information, right? This is the thing. Then we got pure datetime format, date, right? Then if you can ask a question, the very meaningful question. So I wanted to pull the data. We wanted to have only the data for the June, let's say the 6th month, that is the June 2010 from our stock price data set. From this data set, right? We have so many dates, right? I wanted to have only the 6th month, 2010 6th month data. We know that there are only 2. We may have later in the data. I don't know. I'm not really saying it. But the point is, I wanted to pull the data which is from June 2010. How can I pick it up? So instead asking you, let me write it down. Okay. All right, Tesla.log. So, and I'm saying that here, Tesla.log. Tesla is a data frame, the log is a method for that. Then it's going to look for this. Then what I can say here, let me put a condition here saying that Tesla dot the date. Definitely, we have a date, Tesla dot date, right? Date is there. And in which I want to access only the year. Then dt dot year is equals to 2010. But the point is, I'm not interested to pick only the 2010 data. I'm only interested in specific 6th month of 2010 year, right? Then I can say 2000 is equals to 2000. Then I can say here the and, right? And I can say the Tesla dot date dot dt dot month is equals to 6. So only 2 equals. Right, then everything good to go. Then let me take a new line over here. Look at this, we have only 2. In fact, now the confirmation is only 2, we have it. Let's say if I ask you a question, I wanted to pick up the data where it should be 2000 year, but it should be between 6th month to 9th month. So what I have to do? So what I can do, I can take this into one of the brackets, right? Then I can say here, and, right? Then we can say, here we can say, Tesla dot date dot dt dot month is less than or equals to 9 month, right? 9th month. Very well. Okay, we made a mistake somewhere. Somewhere we're missing it. So brackets. So let me come down here. This one, this. Right. This one for this. Okay. This one for this. Very
Last
well.
another one parenthesis.
And here we need to have another one. So yes. Now let us run this. We got so many. We have 66 rows of data. Right? Right. So that's the way you can actually do an analysis. Now the point is, so we came to know that we have this. Let me limit this to. Right. It's okay. Let me comment this line itself. Then, if we can look at the data right now here, so it's a date one. So if I want to change back, same thing. Let's say if I want to change my date column itself as an index, simple. How can I do that? This particular operation is very useful. You know why? Because you may not do the operation on complete data. Any kind of analysis that you want to perform, in most of the situations that you perform the analysis on sample of the data. So the sample of the data, it's definitely 99 percentage that most of the data that includes the date, most of the situations I'm talking about, if it is a banking data, if it is like, the country data, the financial sectors, the financial, like a stock data. But any situations, most of the situations that you find these date columns, then it's more important that if you wanted to pull the data which is from this date to that date, let's say, how can you do that? So you need to have an idea. This is more important thing and one of the most important thing in the complete datetime operations. This one, right? This particular line. However, so we made this Tesla date column as an index. Now there are no more these sequence of numbers here right now. And even if you want to look at that way right now. Well, coming to the point right now. Hold on a second. All right. Coming to here. Let's say if I say the Tesla, now I made the indexes as a date column itself. Now I can actually say like this. If I say the 2015, right? If I say 2015 here, dot ilog of 5, comma 5 columns, let's say. Look at this. Wonder. All right, so we got some error. So we should not be ended this way here. Oh, my bad. This one, it should be ended here. So it's running right now. All right, so we got this, right? Only the 2015 data we picked up. So you can also access this way, guys. It's a very new to you guys maybe, but we can do this way. Suppose if you wanted to access the same thing like 2006, 10 and 6th month, we did this somewhere here, right? So we can do that also like this, the print of the Tesla of, let's say 2010, the date, -06, this, and we can say that ilog of this thing. Look at this right now. Bad. This one. Same thing that we received the data. We can also write this way, but you don't know because we made this index itself as a date. right now. Then we're trying to retrieve the 2010 and 6 month data. We have only two data right now because see the 2010 6 month, 2010 6 month. It doesn't matter, what dates are, right? But is those are in the 6 month itself, isn't it? So you can also do this, right? From this, how many differences? Let us find. We made that index itself as a date right now. We can find it right now. What is the minimum from minimum date from this date index, and what is the maximum also? Then if we subtract it, what's going to happen? Then we're going to get the number of differences. That is, we're going to get the time delta. That is, the time delta is going to give you the number of days difference rather than giving you in the form of this way, the date formatted way. It's going to tell you how many days difference. Now what I'm going to do here, let's say, so let me repeat for you if you want it. Just as we said, the index is a data frame to your date time. To create a datetime index, so we can do the same thing with the time delta to create a time delta index. So how can we do this right now? Say, let's say the Tesla of let's say refer date. If you wanted to, let me make this right now as one of the column. I'm going to make it. I have one column over here, right, is equals to the Tesla of date right now and minus, right? Now look at this, Tesla 8 over here dot minimum. So it's going to tell you what is the minimum date, and it's trying to minus every date. It's trying to minus every date with this date, right? So you're going to get the number of differences anytime that you make, like the 2 days differences. It's going to give you the time delta format. Then this way, the Tesla dot index is equals to Tesla. Let's say I want to make this as this itself as an index right now. No more date. Yeah. So when I'm good,
Yes.
print of Tesla.ilog. Let's say, so my bad. Right, it's okay. This one. Let us see right now. Now I got this. 0 days, 2 days difference, 1 day difference, 2 days, 3 days, 7 days difference, 8 days difference. Yeah.